Hi folks, in this video we're gonna go through base conversions using BC, the command line calculator. Let's start. Let's start with a null conversion from hex to hex. ibase 16, obase 10, 2a is still 2a because decimal 16 in hex is 10. What it means is because you have set ibase as 16, that means obase 10 over here is actually 10 in hex, and 10 in hex is actually 16 decimal. So what it actually doing is it's converting from hex to hex. So here you can see here, if you do ibase 16 and obase 10, then 2a is actually 2a. It's doing a null conversion. Okay, you don't need to worry about this if you write obase before ibase. So if you do this, you can leave obase as 16. So you can see more clearly what's going on. It's converting 2a from hex to hex. So 2a is 2a hex. Yeah, 2a hex is 2a hex. Okay. So that's why the order of ibase and obase matters. Okay, so like here, it's if you put ibase first, then you need to take care of the conversions in obase. Okay. It says the following commands are different. ibase f, it means it's base 15. Obase a is base 10 or decimal. So here C0 in base 15 is 180 decimal, but here it's actually doing a null conversion. Because ibase f obase 10 C0 returns back C0. As with the part 1 over here, it's null conversion because you've set ibase as base 15. That would mean 10 in base 15 is actually 15 in decimal. Okay, so it's doing base 15 to base 15 conversion. So C0 returns C0. So this goes through it again. The first command converts C0 from base 15 to decimal. The second command converts C0 from base 15 to base 15. So this is a null conversion from base 15 to base 15, so it prints C0. We know this because converting 10 from base 15 to decimal is 15. Okay, so here you're setting the ibase as 15 and obase is decimal, so you put 10, it means 10 in base 15, actually 15 decimal. Okay, you can also as I mentioned in part 1, you can avoid this conversion if you write obase before ibase. So if you do this, it's more clearer what's going on. It says ibase is 15, obase is decimal. So here C0 in base 15 is 180 in decimal. Okay, this is a straightforward one. This is a common use. Convert C0 from hex to decimal. The answer is 192. So here you can do ibase 16, obase a, which is decimal, which is 10. So C0 in hex is 192 in decimal. Okay, here you can omit obase a because it's by default obase set as decimal. You can omit obase and it still gives you the right same answer. Binary fun. So what we want is we want to do binary to decimal conversion. Okay, so here because I put ibase first, we need to take care of the conversion conflict in obase like before. Okay, so what we want, because we want to convert from binary to decimal, so we want a binary number that is, when converted, it's 10 decimal. Okay, that's what we're doing here. So ibase is decimal, obase is binary. So 10 decimal is 1010 in binary. So to do the correct conversion, we do ibase 2, obase 1010. So 1010 it's in decimal, and I said 1010. Sorry, I'll say it again. 1010 in binary is 10 decimal. Okay, so we're here converting 1000 as decimal, which is 8. Okay, so here first we check that 10 in binary is 1010. Then we use ibase 2, obase 1010 to successfully convert binary 1000 to decimal 8. Okay, we could do we can avoid the conversion problem over here if you use a hexadecimal number. So here we're doing the same conversion, binary to decimal. We can, if you designate decimal as hexadecimal number A, we don't need to worry about conversion to binary in this case. Okay. Or we could omit this entirely, because by default obase is set to decimal. Okay, next part. Here we use arithmetic expression. This is a addition of two binary numbers. So 1000 plus 111 is 1111. Okay. So here what we are doing is we are converting binary to decimal. So here we were saying 1111 is 15. You can see from this part, okay. So you can use arithmetic expression as the input. Here note ibase A to reset ibase before use. So if you change the ibase from default decimal to some other base, it's sometimes necessary to reset it. Otherwise, it will give you unexpected results. So I'm just setting it back to its default over here. Okay, gotchas. Say you want to convert 17 octal to hex. You know that it should be F, but if you do ibase 8, obase 16, 17, it returns 11. Same reason, because over here we are intending to set obase as hex, but here is actually 16 octal. Okay, so what happened? Since ibase is set to octal, obase is set to 16 octal, which is 14 decimal. Okay, so this is what we just mentioned. But if you do, if you write obase first and set obase as 14 and rest the same, it also gives you 11. Okay, because over here this is 16 octal, which is 14 decimal. Okay, that is confirmed over here. So we're converting octal to decimal. So 16 octal is 14 decimal. Yeah, you can see that ibase 8, obase 16, 17 gives the same result as obase 14, ibase 8, 17. I just mentioned that. How to fix this so you get the result F? What you need to figure out is to convert 16 decimal to octal. Okay, so over here we want not 16 octal, but the decimal, which is 16 octal. I'm sorry, you want octal that is 16 decimal. Okay, So you need to figure out octal that is 16 decimal. This is given by ibase A, obase 8, 16, which is 20. So this is saying 16 decimal is 20 octal. Okay, so we can verify that this is working by ibase 8, obase 2017, which returns f as expected. Okay, so so what if you want to convert from octal to hex? We want a obase figure that is 16 decimal. So here 20 means 20 octal, which is 20 octal, which is 16 decimal. Okay, we can see that by here, which ibase is decimal, obase is octal. So 16 decimal is 20 octal. So if you set obase to 20 after setting ibase to 8, then converting 17 octal, it converts it to hex, which is f. Okay. Alright, more binary fun. Say you want to convert binary 11000000 to hex. Okay, correct result is C0, but you want to insist on writing ibase over obase. That's what we've been doing just for fun of it. Okay, then you need to convert decimal 16 to binary. Okay, so what it means is you want to convert from binary to hex. So we put ibase as binary over here. So in obase, you want a binary which is equal to 16 decimal. Okay. So what I mean is here 16 decimal is 10000 binary. If you put ibase 2, ibase 10000, and if you want to convert this to hex, it correctly returns C0. You can confirm that by putting ibase first. So obase first. So obase 16, ibase 2, and this number here returns C0. So we know that we've been correct. Okay. Okay, so null conversion again. We've been dealing with a lot of null conversions because calculating is fun. So this is the last part, last null conversion. Following command returns back C0. This is because base 15, 10 is decimal 15. Okay, so what it means is after setting ibase as f or 15, it must mean that 10 in base 15 is actually equal to 15 decimal. Okay, we can confirm this. So we're here converting from base 15 to decimal. So 10 base 15 is actually 15 decimal. So we are null converting between base 15 to base 15. So it gives you back C0. Okay. So it says here, since both ibase and obase are base f or base 15, it is a null conversion of base f to base f. Okay, that's it for now. Happy hacking.